Properties of logarithms. Listed below are the three properties that logarithms inherited from exponential functions. These are all in the ln form, but they just as well could be written as log. Number 1, ln of a times b equals ln of a plus ln of b. 2, ln of a divided by b is equal to ln of a minus ln of b, and ln of a to the nth is equal to n ln of a. Now there is kind of an easier way to remember these. If you think of the rules of exponents, when you multiply you add, and that's rule number 1 here. 2, when you divide you subtract exponents, that's rule number 2. And when you raise a power to another power you multiply, and that's rule number 3. These are related directly to those exponent rules, but it's beyond the scope of this class to show that connection. So we just have to remember these three rules. Now let's look at an example. Example 1. Expand ln of mn squared. So think of which one of these three rules would apply. We have the ln of m times n squared. So we're going to do that first. Now what order do you do this in? You really do it in exactly the opposite order of the order of operations. There you do powers and roots first, and here you do them last. So let's take a look at this. This would be ln of what? Yes, we'd use rule number 1. And what do we get? Ln of m plus ln of n squared. So we use the product rule that says ln of a times b is equal to ln of a plus ln of b. And in this case, ln of mn squared is equal to ln of m plus ln of n squared. Now can we continue to expand it? Yes, with rule number 3. What did we do with the 2? We put it out in front. Ln of m plus 2 ln of n. So now we've broken it down as far as we can. Example 2. Expand the log of the square root of a squared b. So now we have to decide what to do with this. Well, you look up there, there's no square root rules or properties. So what are we going to do? We're going to change it into an exponent form. So the log of the quantity a squared b to the half power is the same as the log of the square root of a squared b. Now this is by definition of the square root. This is what it's equal to. So we can just change this. It has nothing to do with logs. But now what are we going to do first? Well, you work outside in rather than inside out. The opposite of the exponent and order of operation rules. So we're going to take and use rule number 3 first. So we have half a log of the quantity a squared b. So now we got that square root thing down in a way. Now what are we going to do next? Yep, the product rule. So we're going to get half the log of a squared plus the log of b. Now we use brackets because that half has to go over all that. We could have used parentheses, but I just chose brackets. And a half has to go times both of those. So then we got, what can we break down next? Yes, that log of a squared will break. A half of 2 log of a plus the log of b. Now nothing else will expand. That's what we get. Example 3. Solve 2 to the x plus b equals 12. So now we're going to use these properties of logarithms to solve an equation. It's an exponential equation. And our goal is the same as always, to get x by itself on one side of the equation. So what are we going to do first? Okay, we're going to subtract 5 from both sides, so we're going to get 2x equals 7. Now we have 2x equal to 7, so how are we going to get that x out of the exponent? We're going to take the natural log of both sides, although we could take log of both sides also. But when we do that, we're going to use rule number 3 now to simplify the left-hand side of this equation so that it's x times ln of 2 equals ln of 7. And then when we have that, now it's just a regular one. We can get the x by itself by dividing both sides by ln of 2. So when we do that, we get that x equals ln of 7 divided by ln of 2. And then when you divide those out on your calculator, you get x equals 2.8073549 on. And we can round that off to approximately 2.81. If you'd have rounded off to 2.8, that'd be fine. I kind of like to leave, since it's an exponent, a little bit more accurate than my normal rule. And so I'd get 2.81, but that's not going to be why you missed the problem, because how you rounded it off, unless you're just like chopped it off to 3. You should at least leave it to the nearest tenth in this case. So this was 3 applications of our properties of logarithms.